All right, folks, welcome to Yak Math videos for your statistics exam number 3 review. Folks, practice this a lot. Your test is definitely going to be shorter than what is in this review, but you do need to know how to do these problems in a relatively quick fashion. Okay, folks. So 2 different parts to your test. First off, got a lot of central limit theorem. You'll probably have 3 of those questions, not 5 like you see here. Remember, central limit theorem there, it's all about z is x bar minus mu. I will give you this formula, divided by standard deviation over the square root of your sample size. Okay, I can use this when I don't see the words normal distribution if my sample size is 30 or more, which it is here. Okay, then folks, you're going to use the z-table. I will print you off the z-table. That's where I'm getting these areas. Okay, I will give you that z-table. You'll have that. All right, folks. Less than 480 minutes. That doesn't make sense when I'm talking about a mean time of 9.5. Well, less than 480 minutes, if there are 50 jets, you just take 480 divided by 50. That's a mean of 9.6. So my x bar, 9.6, goes right there, minus my overall population mean of 9.5, divided by 3.2 is my standard deviation over the square root of 50. Guys, when you do 3.2 divided by the square root of 50, don't round this to the nearest tenth. At a minimum, round it to the nearest hundredth, okay? So when I do 0.1 divided by 0.45, I get a z-score of 0.22. All right, so when I look up 0.22, I get 5871. Now I want to be less than that, and that's what my z-table gives me, area to the left, so I do keep that. Okay, more than, so again, I take 470 divided by 50, that's 9.4. Go about this, I get negative 0.22, all right? So when I look up negative 0.22 in the z-table, I get 4129. Now I want to be more than, anytime I want to be more than, I have to subtract from 1. So notice how I have the same answers. Interesting. All right, if I want to be between 470 and 480, I just did that work. Again, that's an x bar between 9.4 and 9.6. I already have those respective areas. Now, I'm not going to use my answer here, because when I looked up 9.4, which had a z-score of negative 0.22, it was 4129. So I subtract those 2 z-score areas to get 1742. All right, male heights are normally distributed. Guys, I have a sample size that's less than 30, but I see the words normal distribution, so I can still use that central limit theorem, formula. All right, so I want x bar to be 70. I'm going to subtract the population mean, 69.3, all over 2.8 divided by root 25. That is an exact answer there. Z-score of 1.25. I want to be more than that, so when I look up 1.25, in the z-table, get 8944. 1 minus that is 1056. What is the probability that a random sample of 25 males will have a mean height of at most 67.5? All right, so let's look at that. I get a z-score of negative 3.21. So at most means less than or equal to, so I do keep that small probability of 0.0007. What is the probability a random sample of 25 males will have a mean height between 65 and 70.5 inches? All right, so I find both those z-scores. For 68, it's below average, negative 2.32. For 70.5, it's above average, 2.14. Those are the areas, and I want to be between, so I subtract them. All right, possibility this will be 2 videos. Same thing here, folks. Produce company, mean weights, mangoes 9.8, standard deviation 1.7. I want to have an x bar of 9.6 or less. So 9.6 minus 9.8 divided by standard deviation over root 225. 113, repeating. Again, I would write all those out, folks, to get the best z-score possible. The most accurate z-score possible. I want to be less than that, so I do keep that area that I find, that number I find in the z-table. All right, 9.95 is my x bar here. Get 0.88 for my z-score. Now I want to be more. I want to be more than 9.95. So I'm going to do 1 minus what I find in the z-table there. Okay, I want to be between those two. So I have a sample of 150. I don't see the words normal distribution, but just like the last one, my sample size is large enough to use the central limit theorem there. All right, guys, just plug 495 in for your x bar first, find a z-score. Then plug 525 in for x bar first, find your z-score. 0336 is what I find with that z-score. 9452 is what I find with that z-score, and then subtract the two to find the probability it's between. Greater than 515, plug 515 in for x bar right there. Greater than, so I got to do 1 minus what I find in the z-table. And lastly, folks, we've done this gasoline price before. 2.68 is my mu, population mean. 270 here is my x bar. All right, I want to be more than that, so I got to subtract from 1 what I find in the z-table. Less than or equal to, that means I'm going to keep what I find in the z-table. And then right here, okay, now I've already done the one for 270. I've already done the one for 270. So between negative 1.44 and 1.44 for the z-score, again, 9251 was from before. I already did this work right here. This is 0749. Subtract the 2, and 0.8502 is the area between those two z-scores. And folks, we are moving on. Okay, this is from your last quiz. Pair of fair dice are rolled. What's the probability that the sum is 7 or 8? Given that it is more than 6, all of the ones that are more than 6 are 7, 8, 9, 10, 11. There's 21 of them. I see 6 7s and 5 8s. That's 11 over 21. Okay, folks, given that a person is a smoker, so I'm looking at 118. What's the probability that they don't have a college degree? That's them right there. Divide the 2. These are not hard, folks. Okay, these are quick. These are not difficult. Given that a person is not a smoker, so doesn't smoke, has to be my denominator. What's the probability they have a college degree? That one right there. Divide them both. Given a randomly chosen person from the sample, so any of the 800, what's the probability they have a college degree? College degree, there's that many of them divided by 800. Given that a person does not have a college degree, given that they have no college degree, 542 is my denominator. What is the probability they do not smoke? Right there. All right, divide the 2. Given that a person has a college degree, what is the probability that they smoke? So given that they have a college degree, I want the ones that smoke. All right, and that's it. Guys, that is not a difficult question, okay? Conditional probability, first one there. Folks, take a look here, then. Did I skip? Oh, 7 is gone. There is no, oh, that was 7, I'm sorry. That was 7. Okay, number 8, you spin a spinner labeled 1 through 5 repeatedly until, and look at that, folks, I will finally correct that. And in your test, that will finally be gone. It's all about spins, not coin tosses. This counts. This counts as a fix. Probability of success is 0.2. Probability of failure is 0.8. I want to win in 3 or fewer. I went on the first one with a 20% chance. I went on the second one by losing, then winning, 16% chance. I went on the third one by losing, winning, 12.8% chance. Add them up. There's probability. A single urn contains those many balls. 3 balls are selected at random. Calculate the probability. None of them are orange. That means 12 over 20 times 11 over 19 times 10 over 18, which is that. At least one is red. That means 1 minus the probability. None of them are red. Okay, so I want 15 out of the 20 that are not red, then 14 out of the 19, then 13 out of 18. That's the probability none of them are red, so subtract that from 1. That's the probability at least 1 is red. This one's very close to number 8. 40% chance of winning on the first one, then I could miss and win, then I could miss and win. Add them all up. 78.4% chance, basically, that I will win within 3. All right, what you need to do is the probabilities from A and defective plus probabilities from B times probabilities defective from B plus probability it's from C, probability it's defective from C. Add them all up, low probability it's defective. 1 minus the probability it's defective is the probability it's working properly. Given that a randomly selected unit is defected, that's the denominator. I'm only looking at these. What is the probability it came from C? This times this. All right? Basically a 21% chance. Given that it is working properly, that's my denominator. What is the probability it came from A? If 2% of them are defective from A, 98% of them are working fine. Okay, it's a good chance if it's working properly, it's coming from A because 65% of them come from A. All right, in general, they get 65% of their supply from A. What is the probability a randomly selected unit is 1 from B and is defective? So it's both from B and defective, 1% chance. All right, and we're rolling. Feeling good. That one's definitely on there. Folks, independence. If things are independent, then the probability of A and B happening is equal to the probability of A times the probability of B. That is the independence rule that you have to know. If I want to roll a 4, that's a 1 out of 6 chance. If I want to get a sum that is 7, as we know from one of the first ones, there are 6 occurrences of getting a sum of 7. That's all of them. A 1 and a 6, a 2 and a 5, all the way to a 6 and a 1. That's 6 out of the 36 chances, which is 1 out of 6. So probability of A times the probability of B is 1/6 times 1/6, which is 1 over 36. Now, I need to show that I know, what the outcome